Hello guys, this is chapter 6, which is surface area of three-dimensional figures, and I am going to show you how to find the surface area of all of these figures. So let's get started. Okay, the first figure is a cube, and it's a cube because each side is the same. So the base of this side over here is a 9, and the base of this side is a 9, and then the height is a 9 over here. So all sides of this three-dimensional figure are equal, which means it's a cube. So first thing you're going to do, there's two different ways you can do it. You can either use the formula, which is what I've been showing you in class. So that is SA equals capital P H plus 2 capital B. So I'm going to show you the formula way, and then I'm going to show you finding the area using a net and adding it all together. So either way, whichever way is easier for you. So let's start out with the formula. And capital P stands for the area of, or the perimeter of the base. And if you look on your reference sheet, you will find that. And I'm going to show you on the reference sheet where that is. Okay, so at the top of your reference sheet, it is right here, capital P, perimeter of base. And I want you guys to refer to the reference sheet as much as possible, because there is a lot of information on this that you guys are keeping, asking during class, and all the information is right here. So the perimeter of the base is a capital P, and H stands for the height of the prism, and capital B stands for the area of the base, which is right here. So with that information, let's go back and plug in the numbers using the figure, the cube. So the perimeter of the base, and remember the base is the shape that goes throughout the entire figure. So that is the square on the bottom here. So the perimeter of the base is 9 plus 9, and then there's a 9 on this side, and then a 9 on this side. So there's 4 9s, which adds to be 36. And then the height of the prism is 9. And plus your 2, and then the area of the base, and this is a square, and if you look back on our reference sheet, the square formula, which you shall all know, is a rectangle, so that is just base times height. So 9 times 9, which is 81. And then when you go and put in the numbers into your calculator, 36 times 9 is 324, and 2 times 81 is 162. And then all you have to do is add them together, and you get 486, and it is yards, and because we're doing surface area, it's squared. So 486 square yards. And that is how you do it using the formula. So now let's do it using a net. Okay, using a net, all you're going to do is you're going to draw the shape out like you would unfold a cardboard box. So pretending like this is a cardboard box, you're just going to unfold it all. So you're going to have the base in the center, and then you're going to have the outside of one side, the outside of the other, and then this one is going to be a little bit longer because this is the side, but then on this side right here, this is going to be the top of your box. And then this is the other side. So essentially you're going to have 6 sides all together that you are finding the area of. So you actually only have to find the area of one of these boxes because this is a cube. So it's really easy compared to the other shapes, because all you have to do is find the area of one. So this is 9 and this is 9. All of the sides of this shape is 9. So 9 times 9 is 81. And we know that there are 6 sides. There's 2 tops, bottom and the top. And there's 1, 2, 3, 4, 5, 6. So we're just going to multiply this by 6 and get our answer. So that is 486. And it is yards squared. So 486 square yards. So let's look back and see if we got that same answer on the other one using the formula, and we did. So whichever way is easier for you to understand, you can use the formula or you can use the net. I do want to show you that the formula is listed on the reference sheet, so again, you don't have to memorize it, so let me show you that. Okay, so if you look on your reference sheet, the formula that we used was right here. SA equals P, capital PH plus 2 capital B. So either one is fine. I like personally the formula because it's quicker, but if you are able to understand the net process better, then go ahead and do that one. So let's go on to the next shape. Okay, the next shape is a rectangular prism, and we know this because not all the sides are equal, but they are perpendicular and make 90-degree angles. So the base of this is a rectangle, and it goes all the way through the shape, making a rectangle on the top. So the first thing you're going to do, you can use the formula again, doing the same process. So if we were to write the formula out, that would be SA for surface area equals capital P H plus 2 capital B. So the perimeter of this one is 5 plus 2. Remember, there's a rectangle right here. So you have 5 plus 2 plus the other 5 on this side and plus the other 2 on that side equals 14. So 14. And then the height of this prism is 5 because that's the height that the one rectangle travels to the others from the bottom to the top. So that's 5. And bring down our 2 from the formula. And the area of the base, so the base is the rectangle, so it's 5 times 2. Because if you go back to the reference sheet for the area of a rectangle, that's base times height right here. So 5 times 2 is 10. And then all you have to do is do the math. So 14 times 5 is 70. And 2 times 10 is 20. And then you add them together and get 90, and that's millimeters squared. So make sure that you are labeling it. So let's go ahead and do the net version of this. Okay, so for the net version, you're going to draw the base again. So let's see. Let's use red for this one, I guess. So the base is a smaller rectangle like that. And actually, I'm going to need a little bit more room than that, so I'm going to move it down. So the base is like that. And then we have a side over here. We have a side over here. And then we have the side of this one, but we're going to make it a little bit longer to put in the top of the rectangle. And then we have one little side over here, which that didn't look very similar to the other sides. So let's do that one just a little bit again. There we go. Oh my goodness, Mrs. Glenn. Can you draw a rectangle? I don't know. Zebra. Okay, so now we're going to find the area of all of these rectangles and then add them all together. So first I like to actually label the numbers of each of these so that you know how to find the area of each one. So looking over at my original figure, I know that the base of that rectangle is 5. So that means this is going to be 5, this is going to be 5, this is going to be 5, and this one's going to be 5. And then all of these are also going to be 5. And then the distance for the width of the rectangle is 2. So all of these are going to be 2. So now I can find the area of all of these. So again, our formula for a rectangle to find the area is base times height. So let's go back and do base times height for each of these. So to make it a little bit easier, we have 1, 2 of these same rectangles. So instead of doing it and adding it separately, we can actually just multiply by 2 for each of these. So you have 5. I just realized I didn't label these sides. We have 5 here, and 5 here, and 5 here, and 5 here. Okay, so we have 5 times 5 will give us the area of this rectangle and this rectangle down here. So 5 times 5 is 25, and we have 2 of them, so we're going to multiply by 2. So that gets rid of those 2. So let's cross those out, because we've already done them. And then there is 5 times 2 for the smaller rectangles, so that's 10. And there's 1, 2, 4 of those, so we can multiply by 4 for that one. So 25 times 2 is 50. Whoa, that does not look like a 50. Is 50, there we go, kind of. And 10 times 4 is 40. And then when you add them together, you get 90, and it's millimeters squared. Now let's look back, and we have 90 millimeters squared, or square millimeters. So that's how you can do it in 2 different ways. You can make the net, or you can use the formula. So let's go on to the next figure. Okay, this figure is a triangular prism. So the triangle is the base. So you can use the same formula that we've been using before. So if we were to write it again, we have SA equals capital P H plus 2 capital B. So the perimeter of this one is finding the area of, or the perimeter of each side of the triangle. So we have 3 down here. We do not have the slant height for this one. So using the formula for this problem will be actually harder because you don't have all of the information. So instead of doing that, we're going to use the net. So drawing the net, we have a triangle for the base. Then we have a rectangle down below. Then on the other side is the other triangle. And then we have another rectangle over here and another rectangle over here. And when you fold it together, you get your triangular prism. So you have 3 for this one. Let me change the color. 3 for that. 3 for this. And then this is 4. And the height of that is 5. So that means these are 5. And on the outside, we have 5, actually 4, the height of the triangles, which are 5, which will help you when you're trying to find the area of them. And our height of the height of the triangular prism is 4, which gives us the length of these outside as the tops. So then you're just going to break them up and do individually each shape. Like we did before, we have 1 rectangle in the middle, and then 2 on the outside of the same, and then 2 triangles that are the same. So we can break them up by their shape and times them by however many figures there are. So we have 2 triangles, so let's do the triangles first. And the triangle formula for area, if we go back to that, it would be this one for a triangle. And I've written this as BH divided by 2 instead. Dividing by 2 is the same as multiplying by 1/2. So let's go back and do BH divided by 2 to find the triangles. So the base of the triangle is 3 from here. The height of the triangle is 5. And we're dividing by 2. So 3 times 5 is 15. 15 divided by 2 is 7.5. So that means we have 2 7.5s. So 2 times 7.5 will give us 15. So that's for the triangles. And then, so we got that one done, so let's cross it off. So we have the triangles done. Let's do the middle rectangle. So the middle rectangle is 3 by 4. We've already learned before that the area of a rectangle is base times height. So 3 times 4 is 12. And we only have 1 of those rectangles, so we're just going to keep that in the center. That's just 1. And then we have the outside one, which is 4 by 5. So 4 by 5 times 2, well, 4 times 5 is 20, and 20 times 2 is 40. So that's the outside rectangles. And then all we have to do is add all of those numbers together. So we have 15 20, oops, 12 I mean, and 40 to add together. So 15 plus 12 plus 40. So that's 7 and then 67, and it's inches squared. And that's how you find the surface area of a triangular prism. So let's go on to the next figure. Okay, we have a pyramid here, so we can use the formula for finding the surface area of a pyramid, and that is SA equals, let me erase this one, SA equals 1/2 perimeter of the base times the slant plus the area of the base. So let's rewrite that over on the other page. Okay, so I want to tell you again that 1/2 times anything is the same as dividing by 2. So I always like to change it to dividing by 2 because it's easier to do than to multiply by a fraction. So the perimeter of this base is a square, so it's 3 plus 3 plus the other 3 back here, and then the other 3 on the side. So that's 4 3s, which is a 12. And then the slant height they give you, which is 5, so it's 12 times 5, divided by 2, plus the area of the base. And the area of the base is a rectangle, so squares are rectangles, but a rectangle is not necessarily a square. So that is 3 times 3, which is 9. So the first thing you're going to do is the parentheses. 12 times 5 is 60, and 60 divided by 2 is 30. And then we're just going to go over here so we have some more room. So then we have 30 plus the 9 from the area of the base, which is 39. So that is feet squared. So the surface area of this pyramid is 39 square feet. And if we were to use the net, I'll show you on the next page how that's going to look. You would draw the square on the bottom first. So you have the square. Then you have a triangle off one corner, a triangle off the other corner, not corner, side, Mrs. Glenn. Geez, the Ouija pants. Okay, here we go. And a triangle off the other side. So you have a triangle coming off each of the sides, and then when they fold up together, they form a point at the top. So remember, with the net, you're just going to separate each individual shape, find the area of each of them, and add them all together. Now we do have 4 equal triangles, so then you just have to find the area of one of the triangles and multiply by 4. So we're going to label the numbers first. The slant height of the triangle is 5. So these are all 5. And the base is 3 on all sides. So let's do the triangles first, and that again is base times height divided by 2. So the base of the triangle is 3, the height of the triangle is 5, and then divide by 2. 3 times 5 is 15. 15 divided by 2 is 7.5. And we have 4 triangles, so 7.5 times 4 equals 30. And that is for the triangles. And all I have to do is the base of the square in the center. And that is 3 times 3, which is 9. And then you add 9 plus your 30 from the triangles, and you get, let's use a different color. Let's use orange. You get 39, and it's feet, so square feet. So let's look back and see if we got the same answer of the formula. Yes, we did. 39 square feet. So again, either one is acceptable. You don't have to use the formula if that confuses you, but you can if that helps you answer the question with more efficiency. So let's go on to the last figure, which is a composite figure of a cylinder and a rectangular prism. Okay, finding the surface area is a lot different than finding the Actually, you know what I just realized? I never did the cylinder question, so let's do the cylinder question first. And I also just realized that I never included the cylinder in the original front homepage of this video, but that's okay. Alright, so to do the cylinder, you have to break it up into the individual parts. So you can still do the area of the base and do the formula that we were using before. So that's SA equals the perimeter times H, the height of the prism, plus 2 times the area of the base. It's just going to be a little bit different, and I'll explain it as we go. So the perimeter of the base is a circle, and the circle, you can think about like your waist. If you put a belt around your waist, that is called the circumference of your waist. So this is the circumference of the circle. So you're going to find the circumference, and the circumference formula, if you look back on your reference sheet, is located right here, and that tells you the circumference is pi d, or 2 pi r, but I always like to do pi d because it's easier, in my mind, anyway. So going back to that, we're going to do pi d, so that's 3.14 times d, which if we have the radius is 9, to make it all the way across, that would be another 9, so that's 18. And 3.14 times 18 is 56.52. So that is the circumference. So we're going to use 56.52 up for the perimeter. So 56.52. And then the height of the prism is 5. And put down the 2. And then the area of the base is just the area of a circle. And that, again, if you don't remember, can be found on your reference sheet. And that is pi r squared. So pi is 3.14, and our radius is just 1/9. So we're going to square 9. So that's 81 times 3.14, which is 254 times, or 0.34. So I don't have room to write it there. I'll just write it down here, I guess. So when you multiply that together, you have 56.52. Let me rewrite this because it's a little bit cramped. 56.52 times the height, which is 5, plus 2 and 2, 5, 4, 3, 4. So let's do the math in our calculators. So we have 56.52 times 5 is 282.6. And like I told you in class today, I do not want you to round any of the decimals in the middle of the problem. Wait until the very end if it asks you to round. And in these problems that I'm showing you, I'm not asking you to round anything. I will actually round this one to the nearest tenth, just so that you can see how to do that if you don't know. So we're going to round to the nearest tenth. That is terrible, Mrs. Blunt, my goodness. Okay, so we're going to round to the nearest tenth. So then we're going to put in the last part, which is 2 times 254.34, and that's 508.68, and then we're going to add that to the other number, 282.6, and you get 791.28. And in our directions, we said we're going to round to the nearest tenths. So looking at this 8, it's going to either be 5 or more, add 1 more, or 4 or less, let it rest. And because this 8 is bigger than 5, we're adding 1 more to the 2. So that's turning to a 3, and we drop off the 8, and we copy the rest of the numbers down. So 791.3, and it's square centimeters. And let me show you the net version of this. Okay, to find the net of a cylinder, it's actually only 3 parts. and there is a circle for the top of the cylinder. There is a circle, or a cylinder, well, it's a circle because I'm making an oval because of this, the angle of this figure, but you get the point. And then there is a rectangle in the middle. Alright, so you're going to find the area of each of these shapes. So let's first label, this is 9, this one's 9, for the radius of each of these circles. And then you have the height of this rectangle is 5 because the height of the cylinder is 5. So the first thing we're going to do, let's do the circles, which we know the formula is now pi r squared, and pi is equal to 3.14. The radius is 9, so 9 squared, and 3.14 times 81. 9 times 9 is 9 squared. And I think we've done this number before, but that's okay. 3.14 times 81 is 254.34. And we do have 2 circles, so we're going to multiply that by 2 so that we don't have to redo the whole problem again for the other circle. 254.34 times 2 is 508.68. So that's the area of both of the circles, and now all you have to do is find the area of the rectangle. So let's move this over. I'm just going to erase it. If you need to go back and look at the numbers, you can. 508.68. So I'm going to rewrite it over here. Glenn, you can't make your numbers loud. I know. Okay, anyway, so again, like I said before, we're finding the circumference of this circle. And if you were to open up the circumference like you're opening up a label on the outside of a bottle, it's going to actually be a straight line. So the circumference of this circle is the length of this rectangle. So when you open it up, we're going to do pi d to find their circumference. So 3.14 times the diameter, so if we extend it all the way across, that would be another 9, that's 18. And that does not look like 3.14. Let's get that point better. There we go. So 3.14 times 18 is okay, 56.52. And we have that is the side, or this the side distance, the length of this rectangle. So 56.52, we then have to multiply the length and the width together to get the rectangle area. So 56.52 times 5 will give you the total area of this rectangle, which is 282.6. Again, we're just multiplying that by 5, and we get 282.6. So we are adding this number, which is the area of the 2 circles, plus this number to get the answer. So 282.6, which I already have in my calculator, so I'm going to keep it there, and add it to 508.68. And I get 791.28. And if we were to round this one to the nearest tenth, because the directions magically appear, we are looking at, we're changing the 2, but we're going to look at the 8. So the 8 is 5 or more, add 1 more, so we're going to add 1 more to the 3, or to the 2, making it a 3. And so now the answer will be 791.3, and it is centimeters squared. And now you're going to continue on to the next video to watch the composite figure, because I'm running out of time for this video.